All right. So 5 is called the general power rule for integrals, and we're also going to do U-substitution. Okay, so we got two things going on. Okay, so the first rule is the general power rule, which I am going to refer to as the reverse chain rule.
That makes sense. It says it right there.
Yeah. So I always find this notation slightly confusing. Okay, so when you're working with integrals, do you remember that on the chain rule, so if I was going to do a chain rule, I'm actually just going to do this off to the side. So let's just say my function was 3x squared plus 2 to the 4th, right? Okay. To derive it, I would take my exponent, put it out front, so I derive the outside. And then what do I have to do next? I have to multiply by the derivative of the inside. Okay, so just so you know, the notation for this would be, here, let me look at this, right? Do you see right there? Okay, so this is your u to the nth power, right? So in our case, our u is all of this stuff. Okay, so when we derive it, we take the n, we put it in the front, we subtract 1, and then we multiply by the u prime. Okay, so the u prime is the derivative of the inside piece. So now when we go the other way, do you see this notation? So we start with the derivative of the stuff next to it. So it's already in the integral. So what I basically have to do is I have to, do you see what happened? Do you see it in this one? What do you think happened to it? Okay, how would you get rid of it? If it disappeared, if it was here, and then it was gone, how do we get rid of stuff? Kind of. How would we cancel it? We divide by it. Okay, so in the derivative rule, okay, in the derivative rule, we multiplied by the stuff. Okay, when we integrate, we divide by the stuff. Okay, so that's something that's not really written in this rule, and I think that's kind of confusing. Okay, it's just kind of lost. Okay, just so you know, this, I call it the stuff. They call it the hook-on factor. Okay, so the words that they're using versus the words that I don't know why I call it the stuff. Okay, so they just start with doing an example. We can do this really quickly. So this is differentiating it. Okay, so if I derive my 1 plus 5x to the 4th, what would that equal? So it'd be 4, 1 plus 5x to the 3rd, and then I'd have to multiply by 5. Okay, question number 2, so we could simplify this if you want. So we could say this is 1 plus 5x to the 3rd. Okay, so question number 2, the only difference between 1 and 2 is there happens to be a constant that exists in the front first, right? So the only difference here is now we're going to, oh wait, hold on, it says integrate, my bad. Okay, so how are we going to integrate this? Okay, so remember that this is your stuff, right? Yeah. Okay, so we're going to integrate it by adding 1 to the exponent and dividing by that exponent. Okay, so I'm going to have 5, 1 plus 5x to the, what's my new exponent? 4. And then I'm going to divide by 4, because I always divide by that new exponent. And now I'm also going to divide by the derivative of my inside. Okay, so what is the derivative of my inside? 5. Okay, so now we're dividing by that piece. Okay, so when I simplify this, notice that these 5 here cancel. And I have, you can write this as 1/4, 1 plus 5x, or you can leave it as a fraction, that's totally fine. What do we need to not forget at the very end of this?
Plus C.
Plus C, good. Okay, so we're still going to have a plus C after you do all this stuff. Okay. Let's keep trying. We hooked on, right? All right, so let's try question number 3. Okay, we're integrating. So I'm going to add 1 to the exponent, divide by. So I'm going to start with my stuff. So 3x minus 1, what's my new exponent? To the 11th. I have to divide by 11 and divide by 3. Okay, so you can write this as a fraction and just call it 3x minus 1 over 33. Or if you want, you can call it 1/33 times the quantity of 3x minus 1 to the 11th. Either way. Okay. All right, question number 4 is getting a little more exciting. Okay. So the first thing that we have to identify in this one is which one is my stuff and which one is the derivative of the stuff. Okay, so if I look at the two quantities, which one is my original stuff? The first one. No, not the first one. The first one is the derivative. Okay, so this is my u, and this piece is my u prime. Okay, so what's going to happen when I do this is I'm going to ignore my u prime for a second, and then when I derive or divide by the derivative of the inside, they have to cancel out. Okay, so the way I write this is I leave my u prime, I don't touch it for 1 second. Okay, now I'm going to take my u and I'm going to integrate it. So I'm going to have t to the third plus t squared. What's my new exponent?
Squared. 2.
Squared, right? Yeah, so this is still a quantity. This is an invisible 1 there. So what do I have to divide by? 2. And now I have to divide by the derivative of my stuff. What is the derivative of my stuff? 3t squared plus 2t. Okay, now does it cancel with that outside stuff?
Oh my god.
Okay, if that does not happen, you cannot use this reverse chain rule. Okay, so I would say this is equivalent to 1/2 t cubed plus t squared squared plus c. Okay. All right, let's try another one. All right. So for question number 5, this is written as a quotient. Okay, and there is no such thing as a quotient integration rule. Okay, so the first thing that I have to do is I have to start by rewriting this and pulling the denominator up. Okay, so this would be the same as 6x squared times the quantity of 4x to the third minus 5. And what would my exponent be? Good, -1/2. All right, so when I go to do this, for me to use the reverse chain rule, I'm going to kind of do something mentally first. If I derive this, what is the derivative of this? 12x squared. Okay, do I have a 12x squared on the outside? Yeah. Okay, not entirely, right? It's missing a little bit, but I can at least eliminate the x squared. All right, and I'll be okay. All right, you ready? Okay, so I'm going to integrate this. I'm going to leave the 6x squared. Not going to touch it, and I'm going to integrate the u piece. So I'm going to have 4x to the third minus 5. Now I'm adding 1 to the exponent, so what's my new exponent? 1/2. I have to divide by 1/2. Okay, and now what is the derivative of my inside? 12x squared. Okay, do you see how that kind of worked out for me? Yeah, so do you see how I have a 1/2 times 12 squared? What's 1/2 of 12x squared? 6x. So those cancel out just perfectly, right? So boom and boom, that cancels all of it. Yeah, you're right, they're not all going to be that way. Everybody good on that one? All right, let's check out question number 6. All right, so for question number 6, before I start using the reverse chain rule, I want to think about what my stuff is, and I want to drive it and see if it will cancel with the stuff on the outside. Okay, so if I look at my inside, what is the derivative of my inside?
3y squared.
3y squared. Do I have a 3y squared on the outside of this? No. So can I use a reverse chain rule on this? No. I cannot use a reverse chain rule, so how else can I potentially integrate this?
Wait, I'm going to throw it over to get another 3 on the outside.
Right. So it has to eliminate the variables. We can adjust the outside, and I'll show you how to adjust the outside so that the constants are the same. But we have to get rid of variables. You can't invent variables. Okay. So since we can't use reverse chain, how do I do this? Tyler, are you all right there?
Yeah. You probably try.
Alright, so I have to FOIL this out and put it into standard form first. Okay, so if I FOIL this, what's x cubed times x cubed? Add your exponents. 6. Okay, then I have 2x cubed times 1, so that's just x cubed. And then 1 times 1.
Can you explain what you did again, please?
Right here, I just FOILed. This is just me FOILing. Sorry, I just did it in my head.
That's fine. I know, I got it.
Okay, so now I'm in standard form, and I'm just going to do basic integration here. So what is the integral of y to the 6th? Okay, good. And the integral of 2y to the 3rd. Can you jump on this one? Divided by 4, so 2 fourths. Can you jump and say that's going to be 1/2 y to the 4th? Okay. What is the integral of y? I mean, dang it. 1. There you go. Okay, so just be aware, sometimes you can't use reverse chain. Okay, and if you can't, then you have to do your best to put it into standard form, and there might be situations that you just can't do it. Okay? Yep, here we go, U-Substitution.
Just chill.
You'll be alright.
I don't get it.
Okay, so U-Substitution is for more complicated integration problems. Okay, so simple rules for integration might fail, and you have to do something more complicated like U-Substitution. So in this course, a common substitution will be let to be the U. So we're always going to use U as our piece. And we're going to change the variables throughout. Okay, so we're calling it U-Substitution. Okay, so here's the little procedure. So your first step is figuring out and identifying what your U piece is. Okay, so your U piece is always the stuff that's in parentheses or in a radical. Okay, so they're kind of just mostly focusing on the integral right now, or the radical piece, but it can be potentially something that's just in parentheses. Okay, your second step is then to take that piece that you just identified, solve for x, differentiate it, and find dx. Okay, then you're going to substitute it back into the integral piece, integrate it, and then plug it back in terms of x's. Okay, so it's kind of a double substitution. Okay, so first thing that we're going to do is identify what the u is. Okay, so what is the u piece? Okay, the inside, yes. It is the stuff that's on the inside of either the parentheses or the inside of the radical. Okay, so kind of off to the side, we're going to identify that the u is x plus 1. Or x minus 1. Sorry, thank you. Minus 1. Guys, do I need to separate you or... Good? Okay. Second step is now I'm going to solve for x. Okay, so if I isolate my x in this equation that I have, what is my x equal to? Okay, so x is going to equal u plus 1. Okay, my third step is now I'm going to derive it in terms of x. So deriving it in terms of x. So derivative of x is 1 dx. Okay, so we need to make sure that every time we integrate whatever variable, we're going to say like dx, or if I integrate a v, it would be dv. Integrate a u, it would be du. Okay, so what is the derivative of u plus 1? Du. Okay, and that's an important piece because now what we're going to do is in the equation we're going to replace everything in terms of u. Okay, so this is the part that becomes the substitution. Okay, so I have an integral of x. I'm going to replace the x. What is x equal to? Okay, so u plus 1. Okay, x plus 1 is this, or excuse me, x minus 1 is the same as my u. So my second piece I'm going to write out as u to the 1/2. So notice that I'm taking the square root, writing it exponentially, okay, and just replacing that piece with u. Okay, now I have to replace the dx with what it's equivalent to. What is the dx in terms of? Du. Okay, so just so you understand this, I cannot integrate a problem that is in terms of two separate variables. Okay, so if I have a integral with x's in terms of dx, and I do substitution, I need everything to be in terms of u, including the du piece. Okay. So you cannot do a reverse chain on this because, so if you looked at your inside, your stuff would be x minus 1. And the derivative of x minus 1 is 1, and it will not cancel the x on the outside. So we cannot use it. So, yep, get rid of the stuff on the outside, exactly. Okay, so now I just have a very basic equation. I have to put it into standard form first. Okay, so I'm going to distribute the u to the 1/2 through. So what is u times u to the 1/2? U to the 3/2. And u times 1? Or excuse me, u to the 1/2 times 1 du. Okay, so I just distributed it, put it into standard form. Okay, so now I'm going to integrate it. So what is the integral of u to the 3/2? 5/2. So u to the 5/2, if I divide by 5/2, that's the same as multiplying by 2/5. So u to the 5/2. Okay, integral of u to the 1/2. Okay, so u to the 3/2 divided by 3/2. Question?
Where'd you get the 5/2 part if it's 3/2 on top?
Oh, so when I integrate, I add 1 to the exponent. So this is where I'm integrating the x.
Oh, okay.
No, they don't have, it's like you can't combine x squareds with x's. They have to have the same exponent for you to combine them. Okay, so integral of u to the 1/2, if I add 1, that becomes u to the 3/2, which is, yeah, 2/3, wow. 2/3 u to the 3/2. Okay. Yeah, plus c.
Wait, what happens to the du?
Because I integrated it.
So then it goes away.
Yes, when you integrate, you lose your du. Yes.
And that goes
All right, so my very last step here is now I have to replace my du's with what they were equivalent to in terms of x. Okay, so u is equivalent to x minus 1. So I'm going to replace all of my u's with x minus 1.
Oh.
Yeah, the next one is more fun. More fun. Yeah, this one, I feel like this one is about as complicated as it generally gets, and I think if you follow this, that you'll be just fine, and I think that you're totally capable of following this. Okay. All right, so the first thing that I want to do is I want to just kind of bring this up. Okay, so I'm just going to rewrite this as 2x minus 1 times the quantity of 2x plus 3 to the negative 1/2. Okay, so the first thing that I need to do is identify what is my u piece. Good, 2x plus 3. So remember, u is always the piece that's in the parentheses that has the exponent. Okay, so my u is 2x plus 3. Okay, what is my next step? Right before that, isolate the x. Good. So if I solve the x, see if you follow this, I'm going to subtract 3, divide by 2. So x is going to be u minus 3 divided by 2, right? Which, in case you want to make this more simple for deriving, that's the same as 1/2 u minus 3/2, right? Okay, so now my next step from there is deriving it. So what is the derivative of x? dx. What is the derivative of 1/2 u minus 3/2? So what's the derivative of 1/2 u? 1/2. So just going to be 1/2 du. Okay, so now here comes the part where I'm going to substitute all of my u stuff into the equation. You ready? I'm going to do this in green. Okay, so my first quantity says 2x minus 1. So I'm going to replace the x with, So we can replace the x with this one or this one. It doesn't matter. These two are equivalent. I'm going to use this one just because it's going to look nicer. I noticed there's a 2 in the front already. So that'll get rid of the 2 here. So I'm going to put this one into that x. Okay, so we're going to have 2. Wow. 2 u minus 3 over 2 minus 1. Okay, so everybody okay with my first substitution? So first substitution. Now I'm on this piece. Okay, what is this piece the same as? That's my u. Good. So u to the negative 1/2. Okay, and now what is dx equivalent to? 1/2 du. Something. Yes. Okay, I kind of think that is like one of the hardest parts right there. Did everybody follow that substitution? No? Okay, so on this substitution, okay, so I have an x here. I'm replacing this x with what it's equivalent to. So this x turned into u minus 3 over 2, right? So that's where this piece was. Okay, this is the same as this with that one substituted in. Okay, this piece right here, that's the value of your u, right? So I replace the 2x plus 3 with a u, so it's u to the negative 1/2, right? And my last piece right here is the dx. So I could replace the dx with 1/2 du. Okay, so now I have to do some simplifying. Okay, first thing that I notice on this first little term is the 2's cancel, right? Okay, I'm also going to pull that 1/2 that's at the very end into the front. So I'm going to have u minus 3 minus 1, u to the negative 1/2. Everybody okay with that? Okay, so all I did is I canceled these two. So that's u minus 3 minus 1. And I took this 1/2 right here, and I just moved it to the front, because I don't like it back there. Okay, so simplifying a little further, we're going to have 1/2. What's the inside of this going to be? U minus 4. U to the negative 1/2 du. Okay, now watch this. On my next step, what I'm going to do, anytime I have a constant on an integral, I have the ability to take this 1/2 and move it to the front. Okay, so taking it out of the integral and moving it to the front. It's just a constant that's multiplying anyway, so I can multiply it with the integral or I can multiply it afterwards. Okay, so it's just going to become simpler if I move it on the outside, and then I'm going to distribute this u to the negative 1/2 through. Okay, so my 1/2 is going to come out front. What is u times u to the negative 1/2? U to the 1/2, good. And what is negative 4 times u to the negative 1/2?
Negative 4 u to the 1, negative 1/2.
Good. Okay, du. All right, so now this looks a whole lot nicer, and now I can do my integration piece. Okay, my 1/2 is going to hang out front. Now I'm going to integrate. What is the integral of u to the 1/2? So add 1 to the exponent. What's 1/2 plus 1? 3/2. So if I divide by 3/2, that's the same as multiplying by 2/3. Okay. On my second one, I have 4u to the negative 1/2. If I add 1 to negative 1/2, that makes 1/2. If I divide by 1/2, that's the same as multiplying by 2. I already have a 4. You guys stay with me. I'm almost done. Almost done. Oops, and then I get rid.
Hey, it's going good until this problem.
We're almost done. Yeah, this one is complicated.
I kind of got lost.
There's a lot of substitution going on.
That last piece I can do for sure. The rest,
So now we have to put them back in.
after this has.
Yep. So now my last step is to put my u's in. So what is the value of the u? 2x plus 3. Whoops. 2x plus 3 to the 3/2 minus 8, 2x plus 3 to the 1/2 plus c. And now my last step is just distributing that 1/2 through. Okay, so what is 1/2 times 2/3?
Why can't we just leave it?
You could if it was on a simplifying absolute, like the one that just free response. Yes.
Well, it does.
But if it does say simplify, then you should. And I always will simplify. Well, unless. So 1/2 times, yeah. It's just good practice. Okay. So I want you guys to take a look at the assignment.
It's like that.